This issue explores Newton's law of gravity. Galileo tried to study experimentally after the relationship between the motion of the object and the force. Newton based on Galileo's experiments. 3 laws of motion and the law of gravitation were proposed, thus defining the orbits of the planets. In Newton's view, the real effect of force is change, the velocity of the object rather than merely making it move. This means that as long as the object is not acted upon by any external force, it will always remain stationary or with the same speed maintains a linear motion. This is exactly what Newton's first law is about. With Newton's first law, motion is made of. The difference caused by the application of certain forces is stated by Newton's second law. The force acting on the object is equal to the product of the mass of an object and its acceleration. That is, if the force exerted on the object is doubled, then the acceleration of the object will be doubled. If the force does not change, the mass of the object increases by a factor of 2. The acceleration will be half as much. It's like a car, the more powerful the engine, its acceleration. Newton's second law explains further. Why do feathers and pieces of iron fall to the ground at the same time? For objects thrown from high altitudes, if the air resistance is ignored, the external force it is subjected to comes from gravity that is proportional to its mass, and the acceleration produced by this external force is with the magnitude of the external force is proportional to the mass and inversely proportional to the mass. Therefore, heavy objects can indeed gain greater external forces on the one hand, but on the other hand, it will also be due to its own mass without being able to obtain large accelerations. So in the absence of air resistance, feathers and pieces of iron thrown at the same height will fall to the ground with the same acceleration. The time elapsed is naturally the same. Yes. When an object exerts a force on another object will also apply the same size to that object, a force in the opposite direction. To put it simply, each force has an equal magnitude relative to it. Reaction forces in opposite directions are like when we push a wall harder. The wall will also give us a reaction force of the same magnitude at the same time. We talked about it in Chapter 1. After Kepler's discovery of the 3 laws of planetary motion, Newton used the law of gravity to explain why planets orbit the Sun. In fact, it is on the basis of Newton's 3 laws. Newton proposed the law of universal gravitation. The gravitational force is directly proportional to the mass of each object. It is inversely proportional to the distance between them. From Newton's law of gravitation, we derive the gravitational pull of a star is a star like 1/4 of the gravitational force at a distance of half a minimum. This conclusion predicts the Earth with extreme accuracy, the orbit of the Moon and other planets. It was found that if this is concluded in the gravitational pull of stars, as the distance decreases or increases, it grows faster. The orbits of the planets are no longer elliptical. Instead, it spirals over the Sun, or escape from the solar system. Newton's laws of motion and gravitation explains almost all the movements in the universe as we know them, from the motion produced by a bat hitting a baseball to the motion of galaxies. At the same time with the formulation of its laws of motion, another problem that also comes to the surface is that it can be derived from the laws of motion. There is no single static criterion. Next, Newton would have been puzzled by this idea. Einstein, on the other hand, proposed the famous theory of relativity on its basis.